All right, welcome to section 1.1. We're going to get started right away due to the lesson intensity. Here we've got to do 2 lessons today. So just quickly, you can see the objectives are listed at the top, and we have basically plotting points, graphing equations, and using a graph to determine intercepts. This is for your reference so that you'll know if you need to ask any questions or not. All right, we're going to start off with rectangular coordinate system. That just basically means left and right, up and down. No other directions are included in that sort of graphing. You can see the grid lines are straight sideways and straight up and down. All right, so that's called rectangular. It's also sometimes called the Cartesian coordinate system because it is named after the very famous René Descartes. So this dude, it's a French name. There's an accent here that I can't remember where it goes, but basically, perhaps you recognize that name. He's the one that said, "I think, therefore I am," and he's responsible for being, well, he's credited at least with this creation of the X and Y. Okay, there are 4 quadrants. We know there's an origin in the middle. I think you're pretty familiar with these ideas. Okay, so now what? Well, after going through the vocab, X and Y axis, origin, quadrants, and so forth, there's some skills you need to have. For example, you need to graph. And graph is really just a generic verb. It also includes plot. So basically on our first example, we're going to jump right into graphing equations, but you'll be using plotting as you do it. So we're kind of killing 2 birds with 1 stone here. Isn't that a horrible saying? I don't really like that saying, actually. I don't want to kill birds, and definitely not 2 of them with 1 stone. Anyway, so what's going on in this is we're allowing X to change values. We call that the independent variable. So X is independent variable. It just means basically that you're free to choose them, and I've chosen these 7 values. What you're going to do is you're going to plug them all in, and you're going to get a Y for each one, and those are called the dependent values. So as you continue working, you will get a bunch of answers, and those are called the dependent values. All right, this is kind of a lot of writing and a lot of work, but here's what you're going to do. You're going to first plug in the -3 as your X. Then you're going to plug in the -2 as your X. And you're going to continue to plug in numbers for X until you have 7 answers. Those answers will fill the Y column, and then you will plot the points in X, Y ordered pair order. So I went ahead and filled that in for you there, and you can see I basically just put in the -3, the -2, and just kind of on down the page, okay? There's the -3, the -2, the -1, the 0, the 1, the 2, the 3, just kind of slowly plugging them all in. All right, let's see what we get. So for this first one, we get 9 plus 2 is 11. Then we get 4 plus 2 is 6. Then we get 1 plus 2 is 3. Then we get 0 plus 2 is 2. And then you get 3, 6, 11 again, which is more or less a coincidence in the grand scheme of things. But since this is a quadratic function, we're not too surprised to see the repeating going on. All right, so now what we're going to do is we're going to go ahead and plot. What you're plotting here is the point -3, 11. That's the idea. So you're going to plot that as if it were a single ordered pair, like that. And then you're going to plot the point -2, 6, -1, 3, 0, 2, 1, 3, 2, 6, and then 3, 11. And I'm just getting that from the column, the values I plugged in, comma, the values I got out. And you just go through and you plot them all. Sometimes it turns out real pretty. Sometimes it turns out real sloppy. Just kind of depends on the problem. Let's see if I can get these to fit on my graph paper. So -3, 11 would be right about here maybe. -2, 6 would probably be right about here. -1, 3, if I'm looking at this correctly. 0, 6, I said that wrong, sorry, 0, 2 in a minute. 0, 2, and then 1, 3, 2, 6, and then positive 311. Okay, and then since there's lots of x's between -3 and -2, we'll connect here. Since there's lots of x's between -1 and 0, we're talking about decimals and stuff, and also between -2 and -1, and between 0 and 1, and between 1 and 2, and 2 and 3, we're just going to basically connect as much as possible. And that just means there's a lot of other points that exist between -3 and -2, and -2 and -1, and so on. All right, so sorry I didn't say it too clearly, but that's the idea of connecting them together. So we call this a continuous function, and we'll talk more about that later. All right, let's talk about what we just did. So we just basically learned, again, how to substitute and how to plot and how to graph. So we just kind of did a lot there, didn't we? These numbers we're getting on the right, these values are called the independent values. Sorry, my highlighter's not working too good. Try that again. So these output numbers. So the first batch of greens here are called inputs, or you could say domain values. And then these ones over here are called range values, or some people like to call them input-output, and some people like to call them independent-dependent. So, all right, so these are the dependent values in the end. All right, my pen's a little weird today. All right, let's move on. Okay, this one's the same thing. Why don't you try it? All right, did you get the numbers 2, 1, 0, -1, 0, 1? And did you end up with the ordered pairs -3, 2, -2, 1, -1, 0, 0, -1, 1, 0, and 2, 1? I hope so. Okay, and now we're going to plot these. So naturally, you want to give that a try on your own. Hopefully these are the points you plotted. Don't forget, there are more points. There are numbers between -3, -2, -2, -1, -1 and 0, numbers between 0 and 1, and 1 and 2. There are also more points that we didn't plot, out in these regions over here, right? So if you kind of continued this process, you would see more points and more connecting. So this actually goes on forever in both directions, without any breaks or skips. And so the orange part is the portion we graphed, or we call that the domain that we've been given. And then we assume that with an equation like this, there's really no reason we have to plug in these six numbers, excuse me. But we could, and others as well. So the domain is actually not just these numbers, it's any number that you're allowed to use. And then the range is not just these numbers, it's any number that you could get in the right column. And then basically these are the given or the chosen independent values. All right. So we use a few to capture the many is the idea. And if you look down here on the next page, you'll see that there's one more calculation where you do absolute value 3 minus 1, which is 2. You plot the point 3, 2, and that was my first blue point over on the right here. Okay. All right, a couple of things to fill in here. So when you own a graphing calculator, there are some buttons that you want to press to kind of get this graphing done on the screen. So I'm going to model that, and then you can fill in these blanks if you wish. So some of these blanks might be a little hard to fill in, but I just wanted to show you how you could graph, any function really, but maybe this first one, y equals x squared plus 2 on your graphing calculator. So remember, these are allowed for any testing that's AP or whatever. I don't always allow it, but when I do allow a calculator, this is the kind of thing that I'm allowing. And obviously I would definitely not allow you to use something like this. Because allowing a website is more, way more powerful. Plus I have to give you internet access during an exam. So I'm talking about in the classroom, but in general, you want to learn, you want to kind of get used to using devices, handheld devices like this TI-84 calculator, okay? There are other brands, other good calculators you should maybe learn to do too. For example, I've always thought students should be required to learn this TI-89 calculator as well. All right, so let's go ahead and work on the TI-84 though, because more people might have purchased that one. So if you have a TI-84, you first press this Y equals button. and you'll see that there may or may not be functions already in there that someone else has graphed. You'll be using this button here for the x's. So you press x squared plus 2. And it really is as simple as that, and then pressing this last button here, which I don't know if you can see it, but it actually does say graph. It's just kind of white font, and it's a bright light. Let me turn off my lamp, see if you can see it a little better. No, not really. Okay, anyways, this button here. And there you have your graph. There's a lot of cool features when you're graphing. For example, there's a window, which allows you to change which x's are visible and which y's are visible, and by which scale you want to use. Also, another button that's useful is the zoom button. And the zoom allows you to zoom in. If you press 2 and enter, you can see it zoomed in once. Or if you press zoom and you choose option 3 and enter, it zooms back out. Or you can zoom out even more. On these calculators, you typically have to press enter more than once, so just be aware of that. There's a button called Zoom Standard, which is option 6, and that brings you back to the home view or the traditional view. Notice that these boxes on the x-axis are a little bit wider than these boxes on the y-axis, which are a little closer together. That means that this graph is actually being displayed as wider than it should be. So if you actually click on Zoom, option 5 is probably the best way to see the graph undistorted. Just choose that option and you'll see the actual width of the graph, and the x and y interval markings are equal now. Okay, another button that's nice is trace. It's okay for kind of scooting around on the graph using your arrows to see roughly where the points are. But that one's not very accurate, so I would like you to raise your right hand and say, I promise to never use trace for accuracy. Okay? So those middle 3 are nice for when you have a graph on the screen and how you might want to play around with them for studying different features. The most important button, though, is in blue right above F4, and that's the calc button, which really means calculate, not calculus, but there is quite a bit of calculus in here. So, for example, when you get to next year, you'll be able to do things like use option 7 to find the area under the curve, and that's pretty cool. All right, so that's a nice calculator. Let's see how the TI-89 would work. The TI-89 is a little bit more expensive, well worth the money, and it is definitely a little harder to learn to use. Again, you'll press F1, but because it's in green, you'll have to press the green button to access that F1. There may or may not be functions in here, and it might be even in the wrong mode. We always want to be graphing in function mode at the beginning of the year, and you'll be entering your x as the character under the x, y, z choices. So you'll do x squared plus 2, enter. And on this calculator, you have to press enter after everything you type because it's a little more like a computer and it needs to save and archive everything as a variable in the memory banks in a slightly different way than the TI-84. Now you have choices up here as well. And if you press, let's say, graph, which is green F3, you'll see the graph. It's a lot nicer looking. Again, it's distorted. And now you can see that the top of the screen has some choices, and those choices now are considered soft choices with these hard key buttons. So you can press any of these 5 and be able to access any of these features. So I would like to zoom. So I would press F2. I would like to zoom in once. Or perhaps I would like to zoom out. Or perhaps I would like to zoom standard to put it back the way it was. Or if I want those X's and Y's to look the same, I would do a zoom standard, which is option 5. I like zoom standard because, zoom square, which makes each rectangular region a perfect square where the heights and widths of each grid line are the same and the scales are the same on the X and Y axis. This graph is truly undistorted. And even now, if you zoom in from this point, you'll see the graph is undistorted and the X markings and the Y markings are matching. Okay. We still have a trace option. Again, it's not very accurate, so you would raise your right hand and promise not to use it for accuracy. Your calculations is now a little harder to find. You'll notice it's not up here. It's called math now, so you press F5, and here are the same options you would have seen on the TI-84, for example. Let me try that again. because I pressed the wrong button. So for example, if you're under here and you go to option 7, you could, let's say, find the area between the curve and the x-axis, let's say from x equals 1 to x equals 2, and then it shades and calculates that exact area. So that's a calculus concept, but I just wanted to show you that both calculators have that capability. This calculator is more powerful, mainly not from the graphing screen, but it's very powerful in the sense that it has solving features, and that doesn't happen on a TI-84. So for example, in this calculator, you can type solve x squared plus 1 equals 0, find x, and even though it doesn't have any, so because this can't be solved with real number answers, it says false, and the TI-84 cannot do that. If you put a C in front, it will complex solve the problem, and it will give you the imaginary roots. So that's really powerful, and this uses a completely different technology from the TI-84 and its cousins. All right, so this is just a better calculator in general, and it's really not much more expensive. So feel free to fill those boxes, but I didn't really do it. Okay. You can also create a table on the calculator if you like. So let me show you how that works. So remember that your graphing calculator has the graphing feature, and the first thing you would do normally is just go into y equals here. So tap the y equals button. It's the first option here on the left. So you might be starting on the home screen, but when you press the y equals, it brings up what you typed before. Now there's some buttons on here like table and stuff like that, and those buttons are very, very important. So for example, if you can look at these soft keys, again, they're a little hard to see. Let me get it up real close here. Let's see if I can autofocus. Yeah, you can kind of see it there. So it's y equals, it says window, it says zoom, it says trace, and it says graph. But above it,
oh, sorry.
And as you can see, this is called table, not just graph. Because it's written in a different color font, you have to find that button. So because it's written in blue font, it says table, you would press the blue button and then the table feature. You'll notice that this builds an X and Y table very much like the one we built by hand. However, it does it automatically and instantly. Now you can either press plus right now, or you can press second table set to get yourself into this screen. I believe actually second table set works better. So go ahead and jump into this screen. And basically you'll notice how our table had started at 0, but you can change that to start at 11 if you want. And then you can see your table now starts at x equals 11. Or you could press table setup and you can start your table at -4, which is kind of nice, and then press second table to see where it starts at -4 and what the y's would be. You can also go to table set, and instead of just starting at -4 and going up by 1, you can start at -4 and go up by halves. And then you would just basically get a table that goes -4, -3.5, -3, -3, 2.5. So this allows you to edit how you want your table to look. Lastly, there's a mode called auto. I usually leave the dependent on auto, but independent, sometimes I like to change it to ask. The difference is when I start a table, the table's blank and I can pick my own favorite X's, maybe the ones I had on the paper, or maybe something altogether different and creative, like how about something like this? Let me clear these out with delete. What if I just want to put some silly stuff in here like pi? Where's pi? No? I don't know why am I struggling with pi today. There it is. Okay. So it should be second and this up arrow. Yeah. So, whoopsies. So let me try it again. Second and up arrow. Yes, you could put in pi if you wanted to, and that would just be pi squared plus 2 and so forth. So you can just put in whatever you want here. And that's kind of a nice additional feature of a table setup when you put it on Ask Auto. I never really put this on Ask. I usually leave the dependent on auto mode. So those are some really cool features. I kind of almost like the table feature better than the graphing feature, mainly because the graphs are not very accurate looking. but the table you can get as fine detail as you wish to see. The same is true for the TI-89. We already saw that on this calculator, you press the green button and the Y equals to see this, and you can press the graph button, which is green F3, to see the graph. And you still got the shaded part there, sorry. You can regraph it by pressing F4. Okay, so there's your graph, right? But what if you wanted to see a table? So if you look closely, you'll see the table is, again, right above the F5 button. So you can just press the green button. I know it doesn't look very green to your eyes. That's just kind of the way my lighting is in my room, sorry. And then after you press that green button, then press graph. And you can see there's a table here. Again, you can start with whatever X you like. You can jump by ones if you like. Or if you want to go to setup, which is now the F2 soft key, you can start your table wherever you like, make your table jump by however much you want. And for the independent mode, you can put it on ask again. Make sure you press enter a couple times to save it. But what's nice about this is you can basically put in whatever X's you want, like 11, and then on the next line, you could do the pi thing again. So these calculators are very similar. The main difference is not in the location of the buttons, but mainly it's different in these X, Y, Z, the solving capabilities, and just in general, a better looking screen. This calculator also is a little harder to use in some instances, as we'll find later in the year. All right, so that is that. So see if you can fill in this table, not so much by hand calculating, but see if you can get your TI calculator to do it for you. If you still don't have a TI calculator, let me show you how to do it on Desmos.com. This is a very powerful website. And on this website, you can type y equals -1/2 x plus 2. You can see the graph. But what if you wanted a table? So what you do then is you press plus table. And you can see that this table is not called X and Y, it's called X1 and Y1. And you don't need to leave those titles. You can change them to whatever you want, X and Y or A and B or whatever you want. Or if you want to be more specific, just in the Y column, just put the function rule, which happens to be -1/2 x. Sorry about that. 1/2 x plus 2. Okay. Now, whatever x you put in here will give you the correct graph and value on the right. So remember, our function was -1/2 x plus 2. And we're putting in basically all the whole numbers, integers, from -3 to 3. So let's do that. We're cheating a little bit, aren't we? So let's try. So it's -3. Whoopsies. My number lock. -3, -2, -1, 0, 1, 2, 3. This is a very tidy and quick way to do it. You get the points plotted as well. This is gorgeous. You just can't use the internet on every exam, right? In fact, many tests you can't use a calculator at all. But when you are allowed to use a calculator, it's always going to be something, like this. I'm not going to let you use a website, most likely, okay, in most instances. So make sure you know how to use a handheld calculator for testing purposes. So we've seen we can hand plot, and we can also hand calculate. We can also use technology to fill these in and even get the graph. So you should know how to do all of that. And the same is true for this one. All you have to do is change your table to change your function. Remember that whenever you change your function on a graphing calculator, it's imperative that you go back to the F1 and you'll have to actually modify this. A lot of students forget to change this to the new function rule, and then they get the old points again. They don't know what's going on. So whether you have a TI-89 or whether you have a TI-84, you need to press the Y equals button to resurrect the function, retype it. That way you'll be getting new graphs and new table values. See if you can get it to work. It should populate this entire table. And then you'll notice some of the points. For example, this first point is actually going to come out to be negative. Well, it's going to actually end up being -28 here when you work it out. Okay. So you're going to plot -28 And you can see that's not going to fit on the graph paper, but that doesn't mean it's an invalid point. It just means our graph paper is too small to accommodate that point. You'll have to go on to the next view to plot them. So on this, you'll probably be able to plot some of these others, maybe, but maybe not that first one, okay? Maybe not the last one either, okay? So just be aware that sometimes they just don't fit on there. We've seen that before with plotting and connecting the dots. Okay, what does it mean to use a graph to determine x-intercepts? So sometimes the graph is already given to us, and really it just depends on if you know what x-intercepts means. And also the same is true for y-intercepts. If you know what that word means, you should be able to use the graph to get the answer. So when the problem says determine the x-intercepts, you're basically going to be looking for where is y0. And so that would be this point right here. Because this is the point -4, 0, the answer to this question is actually -4. See? So the x-intercept is -4. And on this other graph, it's also -4. You can see it's the exact same location. So in both cases, it's -4 is the x, where the y happens to be 0. So in both problems, your answer is -4. -4. That should say -4. Sorry about that. All right. And there you have the x-intercepts. If you're looking for the y-intercept, it's a totally different thing because you're actually trying to find y-intercept. So the y-intercept is a different thing in the sense that you have to find where is the x equal to 0. So basically, where is x equals 0? And you're not going to give me an x coordinate, you're going to give me a y coordinate. So it's a little bit confusing. So when you're looking for the x-intercept, the y is 0, and you give me the x. When you're looking for the y-intercept, the x is 0, and you're giving me the y. So you just kind of have to work that out. Oh, and I actually did make a mistake on the blue. So for this problem, -4 was the only answer for x-intercept. The y-intercept is this point up here. So you would just give me that 2 right there. Okay, this problem I made an error earlier when I said that the x-intercept was -4. That's not quite true. There's actually a couple of these points. So there's another point right over here. Right, if you pay closer attention, this point is 0, 0. And so it is both an x-intercept and it's a y-intercept if you think about it. So for x-intercepts, it would be -4 and 0. So I wasn't paying attention. So that's not a point. That's not a single point. There's just 2 x-intercepts on that one. And then y-intercept happens to be the number 0, which is, if you look at the orange answer there, you're giving me the y coordinate. Okay, so the black numbers are the x-intercepts, and the orange 0 there, the second 0, is the y-intercept. So a little confusing, but once you get the hang of it, you're just looking for where is x0, that's your y-intercept, and then where is y0, that's your x-intercept. Sometimes we answer with pairs with a comma, and sometimes we just answer one single number. So you might want to just pay attention to the context and see what the book wants you to do. See if you can figure this one out. Where is the x-intercept? Where is the y-intercept? So for the x-intercepts, this is at -1, and this is at +2. So you would actually write x-intercepts -1 and +2. That's an and symbol. Or I'll just write the word. It's a little bit easier to see. Allow me to write the word there. The word and. So it's -1 and 2. For the y-intercept, that's this point down here, which happens to be, I think it's -2, if I'm looking at that right. And where does the graph cross the x-axis is called the, or where does the graph touch the x-axis is x-intercept. Where does the graph touch the y-axis is y-intercept. In other words, where is x0? That's the -2. Where is y0? That's the -1 and the +2. So that definitely takes some practice. But hopefully it's not the first time you've seen it. And that concludes our 1.1 lesson there. So hopefully it was pretty much reviewed for you. And go ahead and start on that homework, right?